Okay, in this video, let's talk about this improper integral from 1 to infinity 1 over x to the p's power. We are going to find out the values of p so that this improper integral actually converges. Well, to do this kind of things, of course, we need two things. First, know our integrations, and second, believe in our limits. So let's get to work. First, to integrate this guy, we actually have to break down into cases. Case 1 is when p is equal to 1. Why? Because you are looking at the integral from 1 to infinity 1 over x to the first power dx. And to integrate 1 over x to the first power, we have to use natural log. So we first do the antiderivative, which is natural log of x. You don't need to put the absolute value because this is positive, so is that. So you don't need the absolute value. Anyway, you can put parentheses if you would like, and then you go from 1 to infinity. And as always, put infinity here and then subtract, you put the 1 there. And you are looking at ln of infinity minus ln of 1. And as you all know, when you have ln of infinity, you are technically taking the limit as x goes to infinity of the ln function. This right here, ln is always increasing and it's unbounded. So you actually get infinity minus 0. Well, this right here is just infinity. In another word, this right here actually diverges because the answer to this is not finite. Remember, converges means that you have a finite sum for this integral. This right here diverges. So we get one number out of the way. Now we're going to consider the rest of the numbers together. Here is the deal. Case 2, when p is not equal to 1. In that case, let's look at this integral as the integral from 1 to infinity. Let me bring the power up, and we are talking about x to the negative p's power dx. Why? Because right here we can just do the reverse power rule. And the reverse power rule is good when p is not 1 in this case, because if you put 1 here, that's negative 1 for the power. Anyway, I'm going to add 1 for the power, and that will be my new power. I will have to divide it by that. So I'll put down 1 over, and let me just put down 1 minus p. Why not, huh? So that's the antiderivative. And I'll write it down. This is going to be 1 over 1 minus p, and we multiply by x to the 1 minus p power. Okay, let's just put it down like this, nice order. And then, of course, we plug in, right? We have the 1 and also the infinity. And now we have some situation, because if you put infinity to here, you are talking about infinity to the 1 minus p power. Okay, let's take a look what that is going to be. We have 1 over 1 minus p, put infinity here, and then raise that to the 1 minus p's power. And then you put a 1 there, so we have minus 1 over, it should be pink, just like that. Anyway, 1 over 1 minus p, and the 1 in there to the 1 minus p's power. This is easy. This right here, do it carefully. All right, so here is the deal. When you have infinity to a power, you might end up with infinity, or you might end up with 0. So which one is what? So let me just put down a note right here for you guys. Of course, I always do things for you guys. First of all, as long as we have infinity to a positive power, it can be positive 0.5, it can be positive 11, it can be positive 17 if you like. This right here goes to infinity. And if you have negative exponent, well, in this case, negative power is what? You bring this down to the denominator. So it becomes 1 over infinity to a positive power. By this, you are talking about 1 over infinity. So altogether, you end up with 0. So 0 is finite, infinity is not. And by the way, you might be wondering, where is infinity to the 0's power then? This right here is indeterminate form, right? But we don't need to worry about the indeterminate form in this situation because p is not 1, right? As you can see, 1 minus 1 would be 0, but p is not 1, so you can never get 0. And we don't have this in that case. So you can just kind of scratch that out. All right, now, I just need to tell you the time that the power here is negative in order for this to be 0. So all I need is that 1 minus p to be negative, meaning less than 0. That's a condition I need. So I will just have to do the algebra. You can minus 1 on both sides and divide it by negative on both sides. Just do the algebra. P has to be greater than 1. This right here is the condition. And when you do have P greater than 1, right? When you do have P greater than 1, this right here will be 0, right? This right here will be 0 based on this. And then you have this right here. So we can write it down as minus. 1 to this power is just 1. So you have 1 over 1 minus P. So like that. And in fact, we can do a little bit more. So if you would like, you can put a negative down in the denominator. So you're looking at, that 0 doesn't matter. 1 over negative 1 minus P. We'll distribute 1 over positive P. Let's put that down first. And then minus 1. Just like this. Very, very cool, huh? So here is the conclusion that I would like to present to you guys. Maybe I'll come back here for you guys. This right here, right? We have two situations. One is when it diverges. This right here, it diverges. If, first of all, let's look at when P is 1, the integral diverges. So there's an equal sign. Well, the only case that it converges is when P is greater than 1. If P is less than 1, by this, it also diverges. So if P is less than or equal to 1, unfortunately, that integral diverges. Which is good, because if it diverges, you don't even have to do anything. And it converges. Let me just write this down. And better yet, I will tell you this right here converges to what? We got it. Right here, when we have this condition, when P is greater than 1, after all the work, it must converge to 1 over P minus 1. So it converges to exactly 1 over P minus 1. And that's when we know if P is greater than 1. Done. So this right here is the conclusion. I call this the P theorem for integral, or if you would like, you can call this the P integral, up to you. So just a real quick example before we go. Suppose you have the integral from 1 to infinity, 1 over x to the 5th power dx. Well, 5 is bigger than 1. So we know it converges. So let me just indicate that. Here, P is 5, which is bigger than 1. So we know this right here converges. This right here, we can just look at this. It converges to 1 over the P is 5. 5 and then minus 1. Of course, this will give you 1 over 4. Very nice, very nice, very nice. Anyway, as always, that's it. Thank you for watching.